students, I hope all of you are doing good. Let's start today's chapter, rational numbers. In this chapter, we will read about some of the topics, and after reading this chapter, we'll be able to know about all these topics, right? Maths extension. Rational number is a number that can be expressed as a fraction, which you already know that. But for some reason, the word rational doesn't have the same pain and fear attached to it as the word fraction has, okay? Which you have already done in class 7. So this is a friendly word. Now let's start. Introduction. The study of mathematics starts with counting numbers 1, 2, 3 and so on, which are also termed as natural numbers. The addition of two natural numbers is always a natural number. The difference between two natural numbers is defined only when smaller is subtracted from the larger one. For example, 3 minus 2 is equals to 1. It is a natural number, but 2 minus 3 is equals to minus 1. So not defined over natural numbers. And 2 minus 2 is equals to 0, not defined over natural numbers. When 0 is included in the natural number, it becomes a complete system and termed as whole numbers. You all are already familiar with this. To answer the question like a 3 minus 4 or a 5 minus 7, integers are defined which include minus 3, minus 2, minus 1, two whole numbers. So integers are infinity to minus, negative infinity to minus 3 to minus 2, minus 1 up to positive infinity, okay. To have the answer for division like 9 by 2 or minus 18 by 6 or minus 15 by 4, we have fractions and a new system of numbers called rational numbers are developed. A rational number is a number of the form p by q, where p and q are integers and q is not equals to 0. Here p is called the numerator, thus p by q. P is numerator, q is a denominator. All the numbers minus 7, minus 5 by 3, 79%, under root 25, minus 2, all are examples of rational numbers because they can be expressed as like this, okay. But the numbers such as 3 by 0 or 11 by 0 are not defined and are not rational numbers. Reason for that is the denominator is 0, which makes them undefined, okay. Example, you have to state whether the statement is true or false, and you have to give reason also. Number 1, all integers are natural numbers. False, because 0 is also included in integers and negative integers are also included in integers. So the answer is false. Number 2, all natural numbers are whole numbers. Of course. Number 3, all whole numbers are rational numbers. True, because whole numbers, that is 2, 1, 2 can be written as 0 by 1, 1 by 1, 2 by 1. Okay, that is in the form of PQ. Okay, so this is also true. Number 4, all rational numbers are integers. False. Integers are minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the rational numbers. Minus 3 by 1, 2 by 1, etc. But all irrational numbers are numbers in lowest term with any denominator other than 1 are not integers, like minus 7 by 3. And number 4, all natural numbers are rational numbers. True, because 1, 2, 3 can be written as 1 by 1, 2 by 1, 3 by 1 and so on in the form of PQ. Number 6, all the rational numbers are natural numbers. False, because 7 by 8, 5 by 7, etc. are not natural numbers. Few of them like 16 by 2 is equals to 8 is a natural number, but not all. So this statement is false. Number 7, all the integers are irrational numbers. True, because minus 2, minus 1, 0, 1, 2 can be always be written as minus 2 by 1, minus 1 by 1, 0 by 1, 1 by 1 or 2 by 1. That is in the form of PQ. No more. All the natural numbers, whole numbers, integers are rational numbers. Remember that. Natural numbers, whole numbers and integers all are rational numbers. Initially they don't have denominator, but in any of these numbers always one can be written in denominator to express it in the form of PQ. Okay, next. Positive and negative rational numbers. A rational number is said to be positive if its numerator and denominator are either both positive or both negative. For example, minus 1 by minus 5 or 2 by 7 are positive rational numbers. A rational number is said to be negative if its numerator and denominator are with opposite signs. For example, minus 3 by 8 or 5 by minus 11 are negative rational numbers. standard form of rational numbers. A rational number is said to be in the standard form if its denominator is positive. Okay. Before moving further, let's know more. Minus 3 by minus 8 and 3 by 8 are same natural rational numbers. Negative is equals to positive, but standard form is 3 by 8. Okay. Number 2, minus 2 by 5, 2 by minus 5 and minus 2 by 5 are same rational numbers because negative positive is equals to negative and positive negative is equals to negative. The standard form is this. Okay. Number 2, numerator and denominator have only one common factor 1, that is HCF of numerator and denominator is 1. For example, 15 by minus 3 is not the standard form. Its standard form is minus 5 by 1. Also 45 by 18 is not a standard form, but its standard form is 5 by 2. That is, it should be in lowest term. Okay. Next, equivalent rational numbers. If p by q is a rational number and n is a non-zero integer, then p by q is equals to p into n upon q into n is equals to p into 2n upon q into 2n and so on. For example, minus 3 by 4, what will we do? We will multiply by 2, then 3, then 4 and so on. So, all these are what? Equivalent rational numbers. No more. For each rational number, there are infinite equivalent rational numbers. Okay. Now, let's read about the properties of rational numbers. Number 1, addition of rational numbers. E. Let p by q and r by s are two rational numbers, then p by q plus r by s is a unique rational number. This property is called closure property of addition. For example, 3 by 5 plus 2 by 7 is 31 by 35 is a rational number. Also, minus 2 by 3 plus minus 1 by 2 is equals to minus 7 by 6, which is also a rational number. P. Two rational numbers can be added in any order. Interchange of place is allowed. Remember that. And this property is called commutative property of addition. So many times you have studied about this commutative property of addition. Okay. So, p by q plus r by s, or you can also write it as r by s plus p by q. Answer will remain same. Okay. No matter in what order you add them up. Okay. Number 3, associative property of addition. For any three rational numbers p by q, r by s and t by u, we have p by q plus r by s in brackets, then plus 1 by t by u is equals to p by q plus r by s plus t by u in bracket. That is, 3 or more rational numbers can be grouped in any order for addition, and associative properties change of brackets or change of row. For example, suppose we have to add 1 by 3, 1 by 2, minus 1 by 2 and 4 by 5. So, 1 by 3, then we will add plus minus 1 by 2 and then plus 4 by 5. Okay. So, what will we get? 6 is the LCM, 2 minus 3, then plus 4 by 5, minus 1 by 6 plus 4 by 5. 6 and if we take the LCM of 6 and 5 is 30. Okay. So, minus 5 plus, here we will multiply by 6, here 6, 24. So, the answer is 19 by 30. Okay. Okay. And if we change the order, then again we will get the same answer, that is 19 by 20. Okay. Example, simplify 7 by 20 plus 17 by minus 45 plus minus 11 by minus 30 plus minus 8 by 15. Okay. So, first what will you do? We will write in the standard form. Minus 17 by 45, this minus and this minus will cancel out, 11 by 30 and minus 8 by 15. Okay. Now, add them up. 7 by 20, we will add these two first, plus 11 by 30, then plus 17 by 45 minus 17 by 45 minus 8 by 15. LCM, if we take the LCM as 20, then 21 plus 22 plus LCM is 45 minus 17, and you will multiply here by 3, 24. Okay. So 21 plus 22 is 43 by 60, and minus will add them, minus plus, but sign will remain minus, negative. So 17 plus 24 is minus 41 by 45. Okay. So 43 by 60, now minus 41 by 45. Now again we will take LCM of 60 and 50, this time we will get 180. Okay. So you will multiply here by 3, here 3 also, 129 minus, here you will multiply by what? You will multiply here by 4. So here also 4. 4 ones are 4, 4 fours are 16, 164. Now subtract, minus 35 by 180. You can simplify it also. 5 sevens are 35, 5 threes are, and 5 6. So minus 7 by 36 is the answer. Okay. Remember, sometimes after the group simplification we get result like 4 by 4, like we did in this example, 45 by 16 plus 10 by 30. If it is like this, then reduce it to its lowest term, 45 60 plus 10 by 30 is equals to 3 by 4 plus 1 by 3, then solve further. Okay. And next, remember, if any integer or natural number or whole number is added, subtracted, multiplied or divided to any rational number, express it in form PQ by taking number 1 in denominator. Okay. Number 4, additive property of 0. If a by b is any rational number, then a by b plus 0 is equals to a by b is equals to 0 plus a by b. That is, 0 is such a rational number which when added to any rational number gives the same rational number as the sum. That is, rational number remains the same. For example, 3 by 4 plus 0 is equals to 3 by 4, or you write 0 plus 3 by 4, answer is same, that is 3 by 4. So 0 is called the additive identity of rational numbers. E, existence of additive inverse of a rational number, that is negative of a rational number. If p by q is a rational number, then minus p by q is a rational number such that, okay, p by q plus minus p by q. Okay, so p by q minus p by q is equals to 0. Minus p by q is called negative of pq, minus pq. P by q. It is also called additive inverse of p by q. Similarly, p by q is called additive inverse of minus p by q. Special case. Okay. We know 0 plus 0 is equals to 0. So 0 is the additive inverse of itself. Okay. Remember, 0 is the only rational number which is its own additive inverse. Okay. Example 4, write the additive inverse of minus 1 by 4, additive inverse is 1 by 4. 3 by minus 7, the additive inverse is 3 by 7, and additive inverse of minus 11 by minus 10 is minus 11 by 10, right? No more. Subtraction is a special case of addition. Subtraction of rational number r by s from p by q is addition of p by q and additive inverse of r by s. Okay. Subtraction of rational numbers. If p by q and r by s are two rational numbers, then p by q minus r by s is equals to p by q plus additive inverse of r by s is equals to p by q plus in bracket minus r by s. For example, 3 by 7 minus 4 by 7 is equals to 3 by 7, which is the additive inverse of 4 by 7, right? 3 by 7 plus in bracket minus 4 by 7 is what? 3 plus minus 4 by 7 is equals to minus 1 by 7. Okay. Similarly, in this case also, 3 whole 1 by 2 minus 1 whole 1 by 3 is what? 7 by 2 minus 4 by 3. So 7 by 2 plus additive inverse of 4 by 3, which is minus 4 by 3. Okay. Now take the LCM, 6 here 21 and minus 8. So 21 minus 8 is 13 by 6, and that is 2 1 by 6. Okay. No more. Subtraction of rational numbers neither obeys commutative nor associative property. Okay. Remember this. Now let's check out the properties of subtraction. Number 1, closure property. If p by q and r by s are two rational numbers, then p by q minus r by s is also a rational number, and difference of two rational numbers is a rational number. Okay. For example, these are the rational numbers and difference of these two rational numbers is also a rational number. B, property of a 0. If 0 is subtracted from any rational number, the difference is the rational number itself. For example, 4 by 5 minus 0 is equals to 4 by 5. Okay, let's do example 5. Subtract minus 5 by 9 from minus 3 by 7. Okay, so let's do it. You have to subtract minus 5 by 9 from minus 3 by 7. Minus 3 by 7 minus 5 by 9. Okay, so minus 3 by 7 plus 5 by 9. Take the LCM. LCM is what? 63 minus 27 plus 35. Okay, so you will get 8 by 63. Okay, so this is the answer. So similarly, you will do second part also. Next, multiplication of rational numbers. If P by Q and R by S are two rational numbers, then P by Q into R by S is equals to P into R upon Q into S. For example, 3 by 4 into minus 2 by 3. So we will multiply numerator by numerator, denominator by denominator. So you'll get minus 6 by 12 or minus 1 by 2. Okay. Properties of multiplication of rational numbers. But before reading properties of multiplication of rational numbers, let's know more. Usually addition and subtraction are easier than multiplication and division, but in case of rational numbers, we cannot add two rational numbers by summing up their respective numerators and denominators. It is pleasant surprise that in multiplication we can multiply their respective numerators and denominators, right? So first property is closure property of multiplication. The product of two rational numbers is always a rational number. That is, if P by Q and R by S are two rational numbers, then P by Q into R by S is equals to P into R upon Q into S is also a rational number. This property is known as closure property. For example, 4 by 5 into minus 1 by 2 is what? Minus 4 by 10 or minus 2 by 5. This is also a rational number, right? Number 2 is commutative property of multiplication. The product of two rational numbers is commutative. That is, if P by Q and R by S be two rational numbers, then P by Q into R by S is equals to P into R upon Q into S is equals to R upon S into P by Q. That is, we can interchange the place, but the product remains the same. For example, minus 4 by 9 and 7 by 8 are two rational numbers. Okay, so let's multiply 4 by 9 into 7 by 8. So we will get here 28 by 72 or minus 7 by 18. Okay. Now interchange the place. 7 by 8 into minus 4 by 9. Again, we'll get the same answer. Okay. No more. Division of rational numbers does not obey commutative property. Okay. Number 3 property is associative property of multiplication. Product of three rational numbers is associative. That is, if P by Q, R by S and T by U are three rational numbers, then P by Q into R by S in bracket, then multiply T by U is equals to P by Q into, then in bracket R by S into T by U. For example, let's take three rational numbers. These are the three rational. Then we'll change the grouping. Okay. As you can see here, and these two are different groupings, but the answer we get is the same. Okay. Number 4, multiplicative property of 0. Any rational number when multiplied by 0 gives product a 0. Okay. Let 4 by 5 be any rational number. Thus 4 by 5 into 0 is what? 0. No matter how big the number is, the product is always 0. Okay. Number 4, multiplicative identity. Multiplicative identity. The product of any rational number with 1 is the rational number itself. If P by Q is multiplied by 1, then P by Q into 1 is equals to P by Q. For example, you are multiplying this rational number by 1, you will get the same answer, right? And therefore, 1 is called the multiplicative identity for rational numbers. Okay. No more. Division of rational numbers doesn't obey associative property. Okay. Next, sixth property, property of multiplicative inverse or existence of reciprocal. Let P by Q be any rational number, then Q by P is called as multiplicative inverse of P by Q or reciprocal of P by Q, and is also denoted as P by Q raised to the power minus 1. Okay. Now, P by Q minus 1 is equals to Q by P. Here, P by Q into Q by P is equals to 1. For example, 2 by 3 is any rational number. So, 2 by 3 into reciprocal of this rational number, that is 3 by 2 is equals to 1. That is a multiplicative identity. Here, 3 by 2 is multiplicative inverse of 2 by 3, and 2 by 3 is multiplicative inverse of 3 by 2. Also, minus 5 by 4 into 4 by minus 5 is equals to 1. So, here 4 by minus 5, okay, 4 by minus 5 is a multiplicative inverse of minus 4 by 4, 5 by 4, and minus 5 by 4 is multiplicative inverse of 4 by minus 5, right? No more. Rational number 1 is reciprocal of itself, that is 1 into 1 is equals to 1. Number 2, rational number is equals to minus 1 is a reciprocal of itself, okay. And number 3, rational number 0 doesn't have a reciprocal because there is no number multiplied to 0 is 1, okay. Next, distributive property of multiplication over addition. For any 3 rational numbers, P by Q, R by S, and T by U, where Q, S, U is not equals to 0. P by Q into, then in bracket, R by S plus T by U is equals to P by Q into R by S plus P by Q into T by U. This property is known as distributive property of multiplication over addition. Let us verify this property. Let 1 by 2, 4 by 3 and 2 by 5 are 3 rational numbers then. First, we will take LHS, see. So, here answer we get 13 by 15, okay. And if we will take RHS, again we will get the same answer, that is 13 by 15. That means LHS is equals to RHS, as the distributive property is verified, okay. Now, division of rational numbers. Operation of division is inverse of the operation of multiplication, okay. If P by Q and R by S are any 2 rational numbers such that Q is not equals to 0 and S is also not equals to 0, then P by Q divided by R by S is equals to P by Q into reciprocal of R by S. So, what is the reciprocal of R by S? S by R, okay. For example, 2 by 3 divided by 5 by 2. So, 2 by 3 multiply the reciprocal of this 2 by 5. So, 4 by 15 is the answer, okay. No more. Sign rules of division. Positive by positive is equals to positive. Negative by negative is equals to positive. Like signs give positive answer. Remember that. Like signs means same signs. And positive upon negative is equals to negative, and negative upon positive is equals to negative. Unlike signs give you negative answer. And number 3, sign rules of division and multiplication are same. Okay. Next, dividing by rational number is same as multiplying by its multiplicative inverse, that is reciprocal. Okay. Now, let us learn about properties of division. Number 1, closure property. If P by Q and R by S are any 2 rational numbers such that R by S is not equals to 0, then P by Q divided by R by S is always a rational number. This property is called closure property. For example, 4 by 7 divided by minus 1 by 2 is equals to 4 by 7 into minus 2 by 1, that is minus 8 by 7, which is a rational number. Okay. And number 2, when any rational number P by Q is divided by 1, the quotient is the rational number itself. For example, 13 by 12 divided by 1. So, 13 by 12 into 1 is 13 by 12, the number itself, okay, the rational number itself. No more. Division of rational numbers doesn't obey. Number 1, commutative property, they don't obey, that is interchange of place. And number 2, associative property, that is changing of groups or brackets, right. Number 3, when any rational number P by Q is divided by itself, it gives a quotient 1. Okay. P by Q divided by P by Q. Okay, so P by Q into Q by P is equals to 1, right? So this is what we can say, that when any rational number is divided by itself, it gives the quotient 1. Number 4, 0 divided by any rational number is always equals to 0. For example, 0 divided by 5 by 4 is equals to 0. Okay, 0 divided by minus 3 by 7 is equals to 0. Remember, division of any rational number by 0 is not defined. We cannot divide any rational number by 0, right? Example 7, verify the property A plus B plus C in bracket is equals to A plus B plus C. When A is equals to minus 1 by 3, B is equals to 5 by 6 and C is equals to minus 2 by 3. Okay. So we have to verify that A plus B plus C is equals to A plus B plus C. Okay. So first we will take LHS, that is A plus B plus C. Okay. So what is the value of A? Minus 1 by 3. Plus, what is the value of B? 5 by 6. And what is the value of C? Plus minus 2 by 3. Okay, minus 1 by 3 plus 5 by 6 minus 2 by 3. Minus 1 by 3 plus 6, 5 and minus 4. So, minus 1 by 3 plus 1 by 6. Okay, and now we will take again LCM, minus 2 plus 1, that is 1 by 6 minus 1 by 6 minus 1 by 6. This is LHS. Now we will find out RHS. RHS is what? A plus B plus C. Value of A is minus 1 by 3 plus 5 by 6 and then plus minus 2 by 3. LCM is 6 minus 2 plus 5 minus 2 by 3. 3 by 6 minus 2 by 3. LCM 6, 3 minus 4. So, we will get minus 1 by 6. See, LHS is equals to RHS, hence verified. The property is verified, right? Similarly, you will do other examples also, okay? Let's do exercise 1.1. Number 1, which of the following are rational numbers? And identify right numerator and denominator. Okay, student, first you will find out which are the rational numbers, and after finding the rational numbers, you will identify the numerator and denominator. So, this is very easy. For example, 2 by 1, this is a rational number, this is the numerator, this is the denominator, right? Basic properties of different kinds of numbers at a glance. Okay. So, here types of numbers are given: addition, subtraction, multiplication, division. Okay. This closure property. Okay. Natural numbers, addition they follow, subtraction they don't follow, multiplication follow and division doesn't follow. Whole numbers follow addition and multiplication but doesn't follow subtraction and division. Integers follow addition, subtraction, multiplication but not division, and rational numbers follow addition, subtraction, multiplication as well as division. Okay. Table 2, what does it say? Commutative property. Okay, so students, go through these table, that is table 2 and table C. Okay, everything is summarized over here. Okay. A, commutative and associative properties are same for all types of numbers or not? Comment on it. And B, if any case if expansions are existing, write them. Okay. 4, role of 0 in addition, subtraction, multiplication, division for all types of numbers. Okay. If A is natural number or whole number or integer or rational number, A plus 0, A minus 0, A into 0, 0, 0 divided by A, 0, but A divided by 0 not defined. Okay. Number 5, role of 1 in multiplication and division for all types of numbers. If A is a rational number, a whole number or integer or a rational number, A into 1 is equals to A, 1 into A is equals to A. A divided by 1 is equals to A, but 1 divided by A is not for natural numbers, whole numbers and integers, because A is equals to 3. If A is equals to 3, then 1 divided by A is equals to 1 by 3, will not be a natural or whole number, but 1 divided by A is reciprocal or multiplicative inverse of A if A is only a rational number. Okay. Number 6, negative of a number. It exists in integers and rational numbers, but not in natural whole numbers, because they are always non-negative. If a is integer, minus a will be an integer. If a is a rational number, minus a will be a rational number. Okay. Number 7, existence of additive and multiplicative identity, and B, existence of additive and multiplicative inverse. Okay. So types of numbers here given: additive identity, multiplicative identity, whether they follow, whether it exists or not. Okay. Natural numbers and rational numbers, additive identity is 0. Additive inverse doesn't exist. Multiplicative identity is 1, and here multiplicative inverse doesn't exist. Okay. So go through this table. Okay. Now table E, distributive property of multiplication over addition and subtraction. Okay. Also go through this table. How very beautifully this has been summarized in these tables. Okay. Next, absolute value of a rational number. Number 1, absolute value is denoted by this sign. Number 2, absolute value of a positive rational number is the number itself. For example, 4 by 5 is a rational number. Absolute value of 4 by 5 is what? 4 by 5. Number 2, absolute value of a negative rational number is always positive. For example, absolute value of 2 by 9 is equals to 2 by 9, that is positive. And absolute value of 0 is 0. Okay. Next, rational numbers between two rational numbers. Suppose we have to find some rational numbers between minus 3 by 7 and 10 by 7. We know that between minus 3 and 10, there are 12 integers, that is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Thus, we can say that the rational numbers are these which are lying between minus 3 by 7 and 10 by 7. There is no limit of finding rational numbers between minus 3 by 7 and 10 by 7. If we write minus 3 by 7 as a minus 30 by 70, and we write 10 by 7 as 100 by 70, then we can find many rational numbers lying between these two rational numbers. Okay. So there is no end of this process. So we conclude that given any two rational numbers, countless or infinite rational numbers lie between them. Okay. To find a rational number between given two rational numbers, okay, let 1 by 3 and 2 by 5 are two rational numbers. Then a rational number 1 by 2 into 1 by 3 plus 2 by 5 will always be between 1 by 3 and 2 by 15. Okay. So also we can write as 1 by 3 as 10 by 30, right? So then clearly 10 by 30 is less than 11 by 30 and 11 by 30 is less than 12 by 30. So to find a rational number between given two rational numbers p by q and r by s, we find 1 by 2 in bracket p by q plus r by s, and p by q less than 1 by 2 in brackets p by q plus r by s is less than r by s. Okay. In example 12, you have to find out the absolute value of minus 2 by 3 is 2 by 3, absolute value of 0 is 0. Okay. First, in third and fourth part, first you will calculate them and then we'll find the absolute value. Okay. Now, representation of rational numbers on a number line. Number 1, natural numbers. Natural numbers start from 1 and extend indefinitely to the right side of 1 on number line. 2 whole numbers, these numbers start from 0 and extend indefinitely to get to the right side of 0 only on the number line. Number 3, integers. Integers are minus 2, minus 1, 0, 1, 2, that is they extend indefinitely on both sides of a number line. But there are no numbers between 0 and 1 or between 5 and 6 and so on. Number 4, rational numbers. The number line in this case extends indefinitely on both sides of 0. Also between any two numbers on this number line, there may exist countless rational numbers. Okay. Suppose we have to express 4 by 9 on a number line. We see 4 by 9 is less than 1 and its fourth part if 1 is divided into 9 equal parts. So 4 by 9 is this. This is how we represent this fraction on or rational number on the number line. No more. Any rational number can be represented on number line this way. Okay. Number 2, the numeral below the bar, that is denominator, tells the number of equal parts into which the portion between 0 and 1 or 1 and 2 has been divided on both sides of line. Equally spaced points will be drawn. 2, 3. The numerical above the bar, that is numerator, tells how many of these parts are considered. Okay. For example, example 15, you have to represent minus 9 by 4, minus 3 by 4 and 7 by 4 on the number line. Okay. All three rational numbers have the same denominator, that is 4. So, minus 9 by 4 is what? Minus 2, 1 by 4. Minus 3 by 4 is minus 3 by 4 only, and 7 by 4 is what? 1 whole 3 by 4. So, minus 9 by 4 means we have 9 markings of distance, 1 by 4 each on left side of 0, and for minus 3 by 4 we have 3 markings on left side of 0, each with a distance of 1 by 4, and for 7 by 4 we have 7 markings each of distance 1 by 4 on the right side of 0. Okay, see the representation, right? Next, example 16, find 10 rational numbers between 1 and minus 1 and minus 3. Okay, so 10 irrational numbers. There, you know that there are infinite rational numbers between any two rational numbers. Okay, so take minus 1. Okay, we'll make the denominator 10, and then also minus 10 by 10, and then we have minus 3. Okay, 10 into 10, that is minus 30 by 10. Now you can easily write down the 10 rational numbers between these two rational numbers. Okay, an alternate method is what? Take the decimal numbers which you have done in class 7 between these two numbers and change them into fractions like minus 2.9, minus 2.8, minus 2.7 and so on, and then change them to fractions like this. Okay. Similarly, in this example also you have to find out the rational number between the two rational numbers. Okay. Let's do exercise 1.2. Find the absolute value of the following rational numbers. Absolute value of minus 9 by 8 is what? 9 by 8. Absolute value of 1 by minus 3 is what? 1 by 3. Okay, students. Now you will do practice of the remaining questions and this chapter.